convex lenses. So a convex lens is the same kind of lens as what you would get in a magnifying glass or what you would get in your eye, because we have convex lenses in our eye which focuses light from a distance to the focal point at the back of our eye where it meets the retina. Now convex lenses are always convex shape. So each face bulges out. Now, what a convex lens does is that it refracts light, and you have to be able to show what the ray diagram would look like for a convex lens whenever it is refracted light. Now, convex lenses are also called converging lenses because they make light converge once it's gone through the lens. So if I draw a couple of rays, we can take a look at what that looks like. So we can put in a couple of arrows to show the direction the light is traveling. And every convex lens has got something called the focal point. So it will be where it bends the light and where the light will then meet once it's gone through the lens, where the light then converges. So it will converge at this thing called the focal point. And you will see the focal point being written as a little f. So there's our convex lens, which is converging light. It's converging because it's meeting at this point. So it's straightforward enough so far. Now, one of the things that you will be required to do is to take a look, or to be able to draw what the ray diagram would look like for a couple of situations that you're likely to encounter with a converging lens or convex lens. So if you take a look at the first instance, this will be where you would have, and you'll always have this, you'll start with your plane of focus. Then you will have a vertical line which will denote the lens. So we draw this here. You will have a set of arrows at the top and the bottom to show that it is a converging lens. And if I choose 3 little squares here for my focal point in front of the lens and 3 little squares behind the lens. So first situation would be maybe that we have an object that we're observing with the convex lens. So if I draw my object here with some arrows at the top to show its position, and I label it O for object, and then need to be able to use the ray diagram to show where the image will form. So the first thing that you want to do, if I select a different color just to show the rays, we get a ray going from the top of the object to where it meets the convex lens. You can always show the arrow. We will also then get a ray that travels from the top of the lens where it goes through the focal point. We will get a ray going through the center of the lens, so we can show that from the top of the object going through the center of the lens. And the interesting thing that hopefully we can see here is that these 2 rays here are never going to meet if they continue in this direction, because they're getting further and further and further apart from one another. So we have to be able to show where these lines would actually meet, and where they would meet would be behind the lens, and it forms what we call a virtual image. So we need to show that these are virtual rays, and we would indicate virtual rays using a dotted line, and we can do the same thing on this side. So we should be able to see that our image, the image will form here. So we label it I for image. Now, a couple of things to take note of here. First of all, you can see that the image is bigger than the object, so it has been, number one, magnified. And second point to notice is that it is in the same position as the object, so it is upright. And we could work out the magnification now as well, but I'll come back to that in a separate video. So that's the first example that you might get where the object is between the focal point and the lens. Now the second one that you might need to draw will be where the object is sitting directly on the focal point. So let's take a look at that scenario. So look at our plane of focus. Use our arrows to show that it is still a convex lens. And put in our focal point. And this time we can draw the image sitting directly on the focal point. Okay, so I can do the ray diagram for this now. I can show a ray traveling from the top of the image to the magnifying glass or convex lens, from the top of the lens through the focal point, and from the top of the image through the center of the convex lens. And the interesting thing that I'm hoping that you can see now is that these two lines are parallel. And if we extend these lines back, in a second, I'm hoping that you will be able to see that these lines are also parallel. They're parallel. They're never going to meet. And this is why if you ever use a magnifying glass or a convex lens with an image at the focal, when you're trying to concentrate on an object, sorry, I should have this labeled as an object rather than as an image, but if we try and focus on an object, whenever we've got it exactly on the focal point, we just get a blurred image. So we don't see an image because the rays are traveling towards infinity. So no image. No image. So the third possibility would be then that you might have to look at what the image would look like if it's outside of the focal range, the focal point. So if I do that scenario now, draw in my plane of focus, draw in my lens again, do my arrows to show that it is a convex mirror, and show my focal points again. And this time I have my object outside of the focal point. So over object. So again, I can take my rays traveling from the top of the object to the convex lens, and take my ray and pass it through the focal point after it's refracted by the lens. Again, I can do the same thing from the top of the object through the center. Move over a bit so you can see where this image is going to form. And there is a third option that you can do, where we're observing where these lines intersect now at this point here, and showing again the direction that the rays have traveled, where the object, sorry, the image has formed where these lines overlap or intersect, or where they converge. Now the interesting thing to note is that this is the top of the object, and if we look at this, where this image is formed, the top of the object, or the top of the image now, notice is the other way around. We say that it has been inverted. It's the first thing we can say. It's upside down. So if you look at an object using a magnifying glass, when it's outside of its focal range, you will see that the image is always upside down. So we have an inverted image. And the second point is that in this instance here, it's the same size. But if we were to have taken it further outside of the focal range, we'd probably notice that it could be even smaller again, in which case we would say it's been diminished. But this is the same size. If I try in a different color, we can take a look at what would happen if we were even further away. So here's our object, and so our image would form here. So you see in this instance here, it would be diminished. That's where our image is actually smaller than the object, and if you try that out with the magnifying glass, you will be able to see that outside of the focal range, the further away from the focal range, the smaller and smaller your image will become, and also crucially that it will be inverted. So that's your three possibilities that you'd be expected to do if you're working with convex lenses and looking at where the images would form whenever you're looking at them inside, on, or outside of the focal point. Hope that helps.